Okay, we're science time now. We're science time, and today we're going to we're going to continue and hopefully finish our discussion about geologic time. Yesterday we talked about fossil preservation primarily, and fossils are an important part of learning about geologic time, and we're going to get to why in a second. But now we're going to talk about how old are things? Well, yeah, very good. Yeah, how old are things? How old are you? Let's start with that. We're going to talk today about. Let's title it this. We're getting into kind of some spooky territory here, where I just ask all the students how old they are, and now we're going to title this lesson "Dating." But the title of this lesson is "Dating," and the geologic timescale, But how old are things? How old are you, and how do you know? How old are you?
14.
You're 14.
From the date of birth.
And how do you know?
Date of birth.
Yeah, that's how long it's been since you were born. And what evidence is there of that? You were there, but you weren't like consciously, or you could say spiritually there. Yeah, you have to rely on evidence, don't you? You don't have any experiences of, what's your birthday, Sage? Get out of the way. What's your birthday, Sage? February 28th of, I assume 2008? 2009. February 28th, 2009. I was a senior in high school. I'm trying to see if I can actually specifically remember that day, because I probably can. I probably have a picture on my phone of February 28th, 2009. Anyway, were you there for that, Sage? I mean, obviously you were to some degree. You were beget at that time. Do you remember it?
No.
No, that would be spooky if you remembered that. Raise your hand if you remember your own birth. Yeah, right. Yeah, right. Cody, explain it to me then. Things were dark, and then they were light. Things were wet, and then they were dry. Things were warm, and then they were cold. And there was screaming. There was loads of screaming. Everyone was screaming. The doctor was screaming. The doctor was like, "Why does it have so many heads? We have to do something about this." No, you don't remember your birth. So you have to rely on external evidence. In the same way with fossils. We can't. My point here is that we can't go back in time and observe facts. Let's just write that on the board. We're going to get that myth quenched right here. We can't, let's phrase it like scientists, we can't go back in time.
Yeah.
This is not really topical because it happened in the 90s. Who killed O.J. Simpson's wife?
I can't remember.
No one. You don't know. And there's evidence to suggest. I mean, there was a trial about did O.J. Simpson kill O.J. Simpson's wife, and we don't know. We don't know because you can't know, because how you would know? Let's do it this way. What color is that flag?
It's red and blue and white.
You just know that because you didn't even look at it. But could we go find out what color that flag is?
Yeah.
We could walk over there and we could take it down and we could look at it and we could see what color it is. You can do that you can directly observe things that are in the present. We can't go back in the past and watch O.J. Simpson's wife get murdered and see who was doing it. We cannot do that. We can't go back in the past and watch Sage get born. That's not how time works. So we need all evidence of the past is indirect. We can't have direct, that is observational evidence of the past. You can't. You can go back and look at records. How much money did I make in October of 2020? Well, I could go back in my email and look at my pay stub and I could find out, but I can't go back in time and get that paycheck again. Yeah, that would be a good cheat code if you could. Just go back to when you got your payday and just pile up the paydays. You can't go back in time, though. So all evidence of the past is indirect. So what kind of evidence? So the real point I'm trying to make here is that to some people, without getting too into politics, but to some people it seems unlikely, or that the evidence isn't good enough that there were ever dinosaurs, for instance, or that the Earth is 4.5 billion years old. The evidence, they don't think, to them, is not good enough because it's indirect. But all evidence of the past is indirect, is part of the point I'm trying to make. So what evidence is there of the past? Now let's talk specifically about the ancient past. Here's one piece of evidence that we just talked about yesterday. This is probably the best piece of evidence of Earth's history, is fossils. Best evidence for Earth's Why do I specify Earth's history?
We don't have Mars' history.
Yeah, yeah, right. Because Mars, as far as we know, doesn't. Well, no, I wish you picked something other than Mars. We can't use fossils to learn about Mercury's history because Mercury does not, as far as we know, have fossils on it. It would be even difficult. The jury, I don't know, as far as I know, the jury is kind of out on is there fossil of any kind of life on Mars. Like I say, the jury's kind of out. But even if it was, it would be significantly harder to use fossils for evidence of Mars's history because, for one thing, it's a long dang ways away. Jose. I'm doing my best. It's history. I'll do it a little slower. What's another evidence for Earth's history, do you think?
Water.
You need to be more specific. I like that one. You need to be more specific.
Land.
Land.
Landscape.
You mean plant fossils, so fossils still.
Land.
Someone said, what did you say?
Tectonic plates.
You
The tectonic.
can't. What do you mean by human stage? I can't ask Jose, hey Jose, what was happening 350 million years ago? She wasn't there. You know what I mean? Human fossils, maybe fossils of human beings, but not really human beings themselves. Like really, even if I asked Jose, what'd you have for supper last Thursday? Right, and that wasn't 350 million years ago. Tommy, you said a good one. What is it? Rocks. Rocks tell us a lot about their environment. Rocks. We can learn about Earth's geologic history. Geologic here referring to what? What's geos, the what of Earth? Yeah, it's related to geography. It's the physical composition of Earth. The rocks and things that make up Earth itself. These are the two probably the most used, maybe I shouldn't have said best earlier, that implies a judgment call that I'm not willing to or qualified to make, but these are the two most commonly used evidences of Earth's history. And then we get into this idea of dating. You guys know about dating. No, I'm just kidding. It's not that kind of dating. It's not dating where you create this is how dating works to an 8th grader. You make a cute little pickup line, and then you get hers or his phone number, and then you text each other, how was your weekend? And everything's spelled wrong, and they say good, and you blush because they texted you back. And that's the entirety of dating to you because you're an 8th grader. And you say, Mom, will you drive me to Arby's with my girlfriend? And you've known this girl for you've known her for maybe 3 weeks, and then your mom drives you both to Arby's, and she pays for both of your lunch, and you eat it, and you all sit in silence, and then you text her and you say, how was your Arby's? And everything's spelled wrong, and then she texts you back and says, good, and and then you blush because she texted you. And that's dating to an 8th grader, but that's not the kind of dating we're talking about, is it? Dating here meaning not going on a date, but assigning a date to some piece of evidence. So let's write that down. So assigning a date to some evidence. Assigning I'm going to put this in quote, date to some evidence. And there are two ways that we date in geology. One is we ask the girl for, no, I'm just kidding. We don't ask the girl for her phone number. I'm not talking about that kind of date. There's two ways that we date in geology, and they are relative dating, which that sounds like now we're talking about going to the family reunion. No, yeah, no, but it's not that kind of relative, and it's not that kind of dating, but it is kind of funny. And we also talk about absolute dating, and we're going to talk about both of those, and I'm going to do them in a different color. Relative dating is as things relate to each other. As evidence relates to other evidence. The example I always use of this is I, David Keim, am older than you, Tommy Tiger, Tegan, Lucas, doesn't matter who you are, I'm older than all of you. I'm older than you. That doesn't tell me what my age is or what your age is, it's relative. X is older than Y. That's relative age dating. And there are different ways that we do this in geology. The most common is this superposition. Superposition is where older things tend to be on the bottom of a sequence. And you think about it this way, the sediment or water, whatever, is getting piled on top. And so the older things end up on bottom. Another example I often use is your laundry pile. Who has a little laundry pile of dirty laundry just sitting on their floor, or their bed, or their chair, or whatever? And someone probably even has a laundry pile on their bed, but they just sleep like cuddling their laundry pile of dirty laundry. I don't know your life. Your laundry pile, where is the oldest dirty stuff? The bottom. You throw it in a pile. Your mom cleans your room for you because you're in 8th grade and you don't do anything for yourself. Your mom cleans your room for you, and then you get home from school, you get ready to take a shower, you put your clothes in a pile on the floor, and that stays there. And then the next day, your mom hasn't cleaned your room. She doesn't clean your room every day. She's not crazy. And you certainly don't clean it every day because you're an 8th grader. But the next day you come home and you put your clothes in that pile. And the next day, and the next day. And eventually you get a pile of clothes, and the oldest ones, the ones from the very first day, the day right after your mom cleaned your room, are on the bottom. When you make a pizza, what's the layer that went on the countertop the first? The crust. Yeah, you had to put the crust there first, because if you put the cheese first, and then you put the... Could you? I mean, seriously, you could. Do you? Is that wise? Does that... Let me phrase it this way. We're not going to imply an intelligence in this situation. What could that happen? Yeah. Is that the most likely thing that happens? No. So superposition is that older things tend to be on the bottom. Because even in real life, superposition is sometimes subverted. Sometimes an older thing through plate tectonics is now on the top. Sometimes that does happen. We call that overturning of rock sequences. So older things, though, usually, most likely, probabilistically, statistically, they are on the bottom. And there are other evidences. So let's look at it this way. Let's use the pizza analogy again. What would be the evidence that someone had made the pizza upside down?
Well, if the crust was on the top, if the bottom of the
No, because you're yeah, if what? If when, how would it be different? If I brought you two pizzas and I said I made one of these upside down and one right side up, would you notice a difference in them?
Yes.
Probably. Yeah, you probably would, because there would be some evidence that it had been upside down. And that is superposition. There's other evidence that in rock layers, so we talk about it as pizza. Here's the pizza crust. Here's the pizza sauce. Here's the little olives. Here's the cheese. Right? And I had to do them in that order to get them in that order. It's the same thing as rock layer A is older than rock layer B, is older than rock layer C, is older than rock layer D, etc. So this is the youngest, or what we say most recent, and this is the oldest. It's the same exact principle, and this is called superposition. Is it possible that plate tectonics or some other force can cause this to flip, at least to some degree? Yeah, but then we have evidence. There's evidence that that flipping has occurred. There's some faulting, maybe, or there's some angle. These are not at a perfect angle, and that tells us that some degree of overturn has occurred, and so this superposition has been subverted. And there are other rules of relative dating that your book goes into, and I would like you to look at those, but we don't have time to talk about them now. But in general, this is telling us things like this fossil. Let's say we find a fossil in layer A, and we find a fossil in layer C. Which one is older? A is older than C. It doesn't tell us A is 17 million years old and C is 12 million years old. It just tells us A is older than C. That's relative age dating. Relative age dating is not Wes is 14, Mr. Snitley is 33. It tells us Mr. Snitley is older than Wes. Does that make sense?
Yep.
That's relative dating. Absolute dating is when we get an actual numerical date. This is going to be the last thing, obviously. We get a numerical date. You will have to look up on your own how those numerical dates are achieved. In the example, this would be like saying Lucas is 14 years old. Mr. O is 41. Those are numerical dates, and that's absolute dating.